Okay, so number 10 and 1.2 is vaguely nasty. So as I recall, it's something like y of x is c squared plus 2cx. No, cx.
Plus 2c plus 1.
Plus 2c plus 1. Dang it, that was close. And they want you to show that this satisfies y prime equals minus the quantity of x plus 2 plus the square root of x squared plus 4c plus 4y.
4x.
Sorry, say again?
X squared plus 4x.
X squared plus 4x plus 4y.
Yeah.
And then this crud is all over 2. Okay. So, this should be easy because y prime is what?
C.
Yeah, this guy just tells you y prime is c. So this whole business seems like way too friggin' complicated, right? Because this is supposed to reduce to c?
There's not even C.
Like, that's just a dirty trick, man. There's not even any c's in this shit,
Well, it should be.
right?
You just plug in where all the C's are in the first one.
Okay, so there's supposed to be a c, right? And then y is that stuff with c's in it. So it's supposed to be minus x plus 2 plus the square root of x squared plus 4x plus 4 times all of c squared plus cx plus 2c plus 1. Okay. Right?
Over 2.
All over 2. Because why not? Okay, so I'm presuming that you guys all had some difficulty and that difficulty rests right here. Right? Because somehow you're supposed to get something out of that that's sensical. So in that thing, I'm just going to play with that part. Right? So call the crap under the square root star. Now, things I know about star. Star is x squared plus 4x plus 4c squared plus 4cx plus 8c plus 4. And of course, you would notice that that's x squared plus 4x plus, oh, what was my order for this? Plus 4cx plus all the stuff without any x's in it. So there's a 4c squared plus 8c plus 4. Because of course the naivest thing you could do would be to write this like a regular quadratic, right? Okay, so if you write it like a regular quadratic with parentheses, then it just gets worse, except it doesn't, because it's better. Yeah. But you have to notice something. So you got 4, what was your coefficient on x here?
4 plus 4c.
Yeah, 4 plus 4c is your coefficient on x. Right, because of course this. And then you got all that junk, right? 4c squared plus 8c plus 4. Okay, then, if you are a clever algebra student, no, don't do that. You will notice that this thing here is a psst. That is a perfect square trinomial. A perfect square trinomial is what you get when you take a plus b quantity and square it. Right, so if you square the quantity a plus b, what do you get?
A squared plus 2ab.
A squared plus 2ab plus b squared. Right? So I'm left wondering, like, okay, so I got something squared here. It's specifically x. And then here, you guys notice anything about that?
It'd be like a B squared, I guess.
That's another.
Yeah, that is itself a PST, right? This thing is what squared? That's 2 plus 2c squared. Cool. And you definitely got an x squared. And then the kicker that makes this thing, all told, a PST, right, is that this is the middle term, right? This is twice the first thing times the last thing. You guys see that? So this guy here is 2 times 2 plus 2c times x. And so, of course, this whole thing is what?
X plus 2c plus 2 squared.
X plus 2 plus 2c, all squared. And then you can trot that back into your square root. You guys see that? So, in the end here, you got c equals minus the quantity of x plus 2 plus the square root of x plus 2c, 2 plus 2c squared, all over 2, right?
Yeah, it simplifies.
Okay, and then naively, right, you could, yeah, you could knock off the square root and the square, right? Okay, well, that really should be an absolute value, right? You took something, squared it, that's going to make it positive, and then you fed it to a square root. That's going to give you a positive thing back out. You guys see that? Like if you took -3, squared it, and then square rooted the result, you would get, no, you would get very specifically +3. You didn't put the square root in. It already is the positive branch of the square root. You don't get to pick. So this thing is really specifically already 3. So squaring and then square rooting is literally the absolute value function. That's another way to define it. Right? I defined it as a piecewise function the other day. You guys remember that? But this would be another way to define the square root function. Or sorry, the absolute value function. So if you cross these out naively, right, then it's pretty obvious that most of this stuff cancels and you're good to go. But to cross out those naively, what do you need?
That thing can't be 0.
Close.
You want the
Or less
assurance
than-
that it's not
It can't be
negative.
negative.
Yeah, you want the assurance that it's not negative so that it is actually the same thing, right? So that blue bit is true when x plus 2 plus 2c is
Bigger than 0.
strictly bigger, well,
Or
bigger
equal
than or
to.
equal to 0. Anyway. You guys cool with that? So that tells you, they're also asking in this question, right? Not only does this solve, but they're asking when does it solve? So when does it solve? You guys see that the when came up right now? The when it solves is right here. Right? That's true when x is bigger than -2 minus 2c. Is that? So that's an interval, right? Cool. That help on that one? Yeah. Yeah, so it certainly could be less than 0, but if it's less than 0, then this guy won't cancel with that stuff, because this stuff will be the opposite of what it was before.
Okay.
Does that make sense? Like, if this thing that I feed in there is negative, then what I get out doesn't cancel with this guy, because it's got absolute value bars on it, and you can't get them together. example.
That is a C, right? So wouldn't you would answer like y of x equals to all of that squared plus all of that times x plus 2 times all of that plus 1 is equal to, it is true when that's greater than 0, right?
Oh, so I would say this guy, right?
Yeah.
Your y of x solves this guy
Okay.
on the interval starting with that, right?
Okay.
Or when x that.
And you wouldn't have to plug that C into the y to kind of show like here's like.
No, the c is an arbitrary constant.
Okay.
And the c changes two things. It changes the solution that you're getting, and it also changes the interval on which that solution works. Does that make sense? Like it's got two effects. It's not just changing the function value itself, it's also changing the when is that solution valid. Go with that? Questions then? Okay.